Ladies and gentlemen, thank you very much for giving me a voice. I will today talk about the two possibilities of link cellulose decomposition of wood. First, using ionic liquid called alkali solution called acetylcholine chloride, and other by mushrooms. Lignocellulose is important component of agriculture waste. It is building the plants, and application of it, especially food and for treatment, produce much of waste. The lignocellulose is containing of hemicellulose and cellulose, which are very fine material for fermentation and other compounds in polymerases also, and biological and many application, while lignin is needed to be separated because inhibits the fermentation processes and need to be separated first for efficient processing of two waste components. And first is using the roots and rod fungi, and work is based on Professor Yang Xia from London University of Brunei and Professor Bei Luo from Yunnan University, and work is fungal selectivity and biodegradation effects by white and brown fungi for wood biomass treatment. Both and from, in case of choline chloride, which is alternative because it's not solvable in below 100 Celsius in solution, and this is based on polymers work from Nanjing Forestry University by Professor Yang Wu, and work is for compressible cellulose wood prepared with deep alternative solvents and its improved technology. Both works are containing mostly on softwood and pine tree, because pine tree is a very common tree and commonly used in furniture. Thus, waste is very common. The wood is with, of course, there is trouble is that there are unlikely pine wood to be acidic for treatment because it blocks very common due to gumoniazo occurring, and this causes to other methods. One is the pine wood, the rotwood, white and brown wood, the fungal qualification. And in case of check what is better, white or brown rod. White converts hemicellulose and lignin without cellulose, while brown rod contain only the all three compounds. In case of Antarctic, it's mostly the lignin leaving mostly the lignin leaving only hemicellulose and cellulose. The sample in case of choline chloride structure was based on national renewal test, so content was checked. Lignin conversion was by initial mass and rate and of how it changed. Similarly to the word contain, and this shows us that in case of lignocellulose after pretreatment, there was in case of mass percentage, the conversion of lignin in case of choline was slower to 19% from 30% in lignin in pine tree. In case of chlorine chloride, and while in case of white rot, it was much better than brown rot, but still only 6% to 24%. This shows that and much less slower than in case of Antarctic, but a much cheaper. And this shows that the promising solution would be some genetically modification, and then maybe using this Antarctic if would be from green chemistry. And this is the trouble that is not this contained from green chemistry as soon, and this shows the trouble of the eutectics that still needs some work because choline chloride is can be used as waste from pharmaceutical energy industry, but it's still quite expensive. But this is a very important that we check both biological and chemical way to solve our trouble with lignocellulose waste. Thank you very much.